In this video, we are going to discuss the difference between an ammeter and voltmeter. An ammeter is a device that is used to measure current, whereas voltmeter is a device that is used to measure potential difference across a circuit. An ammeter is generally denoted by a circle with capital A written inside it whenever you have to show it in a circuit. So if I were to draw a circuit with an ammeter, I would draw a battery, a resistor, and the ammeter you can show as a circle with an A in it. A voltmeter, on the other hand, has a similar structure, a circle, but with capital V. So if I were to show a voltmeter in a circuit, I will draw a circle with V. Ammeters are always connected in series. So whenever you connect an ammeter in a circuit, you have to connect it in series with the circuit. Voltmeter, on the other hand, are connected in parallel. So for whichever component I want to find potential difference, I must connect the voltmeter across that component. I must connect it parallel to that component. Resistance of an ammeter is very small, whereas resistance of a voltmeter has to be very high. Now, why is this the case? Why do we need an ammeter with very small, almost negligible resistance? So if I have a series circuit, let's say I have two resistors R1 and R2. The current in this circuit will be given by I equals V over the equivalent resistance, which will be V over R1 plus R2. If I have to measure the current in this circuit and I connect an ammeter, I will connect that ammeter in series with it. So let me connect an ammeter here. If this ammeter does not have negligible resistance, if the ammeter has certain resistance R, and this R is significant, then this resistor will make changes to my circuit. It will make changes to the overall resistance of my circuit. And now when I'm measuring my current, it won't be the original current over here that we had. You will get a new value of current I, which is V over R1 plus R2 plus the resistance of the ammeter. So if the resistance of the ammeter is not negligible, it will affect the value of current in my original circuit. So before, when I had not connected the ammeter, my current was V over R1 plus R2. If this resistor is not close to zero, if it is not very small, it will change the current value when the ammeter is connected. So that will not give you the accurate result of the current. It will give you a different value of current. So this resistance small r must be very small, so we can neglect it in comparison to R1 and R2. This is why resistance of the ammeter must be very small so that it doesn't change the actual current in the circuit. On the other hand, a voltmeter must have very high resistance. Why is that the case? Suppose if I have a circuit, this V, and this battery is connected across a resistor R. Let I be the current in the circuit. If I want to find what is the potential difference across R, you can calculate that as V across R equals I times R. When I use a voltmeter to measure this potential difference, I connect it in parallel to my resistor. If the resistance of the voltmeter was not high, if this resistance was small, Then we know in a parallel circuit, current always divides, and more current will flow through the part which has lower resistance. So some of my current will bypass the resistor R here and flow through the voltmeter. And if the current starts to flow through the voltmeter, the potential difference that my voltmeter will measure at R will not be accurate because not the entire current of the battery is flowing through R. This is why the resistance of the voltmeter must be very high so that no current passes through it. No current from my original circuit passes through the voltmeter. Because for a parallel circuit, current will pass through the branch which has the minimum resistance. And if my voltmeter has very high resistance, no current will pass through the voltmeter and all of my current will remain in the original circuit. That will give me the accurate value of potential difference. So this is why resistance of ammeter must be very small, whereas resistance of voltmeter must be very high.